Hello and welcome to this episode of the Building Sciology Poddie. My name is Jess Kismet and I'm going to be your host, and today joining me is Sean Maxwell. Sean Maxwell is the Atma Scheme Manager for Australia and New Zealand. Sean has just ticked over 20 years of blower door testing experience and building science experience. He's a New York expat, and after moving to Australia for love, he has taken on the Australian building industry and is leading the charge for forward movement and adoption of airtightness testing as a way to improve our buildings, commercial and residential. Our industry is full of really passionate people, and Sean is right up there as the leader of Australia's growing community of building science professionals. He is endlessly generous with his time and knowledge and shares this with designers, builders and project teams through training and tireless industry advocacy. His biggest contributions to date include improving the airtightness regulations in the Green Star framework for the commercial space and requiring airtightness to be considered during the design phase and not just tacked on the end. And most recently, the publication of the document called The Air Infiltration of New Dwellings in Australia, published by the CSIRO. We'll talk about both of those things more during our conversation. So now, without further ado, welcome, Sean, to the Building Sciology Poddie.
Hello. Nice to be here.
Thanks for joining me. In the intro, I mentioned that you're the Atma Scheme Manager. Can you tell us what Atma stands for and what it is, where it sort of a bit of a backstory and how you became involved with them?
Sure. Well, first I gotta say, you mentioned that I moved here for love. Well, that's true, but I gotta tell you, I'm glad to talk to you just because my wife does not actually like talking about blower door testing all day long. So it's good to talk to somebody. So this is great. Thanks for having me. I really appreciate it.
You know, we can talk about it underwater.
Yes. So Atma, when I moved to Australia from the US, so I had been doing testing for Energy Star homes when I first started, and then through energy conservation programs in New York. And when I moved to Australia, I was looking for other people doing testing, and really it was pretty lonely here. It was like
so
crickets.
When did you move here? What year?
2015.
Okay, so I met you not long after that. I met you in about 2018.
Yeah.
So you hadn't been here all that long. So
right.
Sean, for the listeners, Sean actually trained me and certified me for Atma blower door testing back in 2018.
Yeah, it was a while ago. Yeah,
yeah,
you were one of the early ones.
I know. I was writing the intro and I was like, was it 7 years ago? So I looked back at my photos and I was like, yeah, it really was 7 years ago.
It really was that long ago. You've been at this game for a long time.
Yeah. Anyway, sorry. Carry on.
Well, so when I first moved here, it was like looking for anybody doing this. Hello, anyone? And I was also, I really got into building codes and trying to get something into the building code in the New York State building code. And to do that, we were compiling a database of blower door tests. And so I came here and I was looking to do the same thing, like let's build a database so we can make the argument that this is a good idea. And so going around asking people in the government if we could get some money to build a database. And then as I was searching for database, this on the web it came up. Atma had this database called Atma Lodgement. And so I asked, can I join you guys? And sure. So I was the first one in the Southern Hemisphere to join Atma, and they gave us access to this database. So Atma is the Airtightness Testing and Measurement Association, and that's really, they're people who really care and are focused on airtightness testing as a discipline and as a regulatory tool. And I'd say their killer app is Atma Lodgement, their database. So the thing about blower door testing is, yes, you can use a blower door as a qualitative testing tool, like you can find leaks with it, walk around, feel with your hands where the leaks are. But at it's also a pretty effective quantitative test. So it lends itself actually to analysis. This data that we get, you can upload to the Atma Lodgement database. It scrapes the data from the test file and then spits out analysis of your results. How consistent is the data? Does it follow the laws of physics? I mean, is it realistic? It flags things that look suspicious. and it's getting more and more. There's more and more levels of quality control. So that's really how I got really into it. Was I thought, wow, this is cool. This is going to enable us to get some regulatory change.
Right. I bet Barry Cope is the scheme manager in the UK. So ATMA is actually originates from the UK, right? So you
Yes.
contacted Barry Cope in the UK. I bet he was stoked to hear from you.
Yeah, yeah, and he was stoked to come down here and spread the gospel.
Yeah, yeah, sure. Um, so for those who don't know what a blower door testing is or an air tightness test is, could you please give us a quick overview of what happens on a blower door test day and why it's used?
Sure. It was simply named a blower door because it's a blower, a fan in a door. So it's a temporary rig that you put up in the front door of a house, for example, and it pushes air in or sucks air out of the house, and then air has to come in or flow out to replace that. And you can measure how much air you're pulling out and what the pressure is that it develops, and then you can write those numbers down. And uh, now this test has been done around the world. Uh, Definitely around the world millions of times. And so you get a pretty good idea of how a building overall is going to behave with a blower door test. It's pretty simple. You put a fan in the door and you suck the air out and you try to see how well does it hold on to the air? How well does it keep the outside out and the inside in? It's pretty simple test and there's a lot of things that it sort of glosses over, like doesn't tell you whether the leaks are high or low, doesn't tell you how much it's going to leak exactly during any particular weather, but it gives you a pretty simple way of evaluating house to house, apartment to apartment, building to building. Let's have a fair basis of comparison. So that's why it's pretty cool, simple but effective.
And why do we use them? What's the purpose of a blower door test?
Well, it's from Atma's point of view, and my focus really is first, it's a quality control tool. So, like I said, it's a very simple way of assessing overall build quality, but that's really it's at its most basic and its most glorious. It's a simple quality control tool. It's like how well do you keep the outside out? So very simple.
Yep. And because if you've got, unnecessary leaks in your walls and your roof, then you're losing a lot of air that you are conditioning, right? So you've got your air conditioner pumping. It's 35 degrees outside, let's say you're in Adelaide where I am, and it's a hot summer's day, and you are conditioning your air, and as soon as you turn your air conditioner off, all of that conditioned air just goes whoop out of all of the gaps and cracks.
Sure.
And so that's why we want to be able to quantify what the air tightness value of any building envelope is, so that we can, and then discover where those leaks are so we can seal them up, right?
Yeah, and I'd say even more than quantifying, well, like quantifying, like knowing what the number is, basically the basic thing is less is better. So there's no good argument for having more air leaks through your wall assemblies or your ceiling assemblies or your floor assemblies. It's not a good thing. It's not a good way to dry out your building. Not not really. We're not saying that you should seal the house up and that you can't open your windows. Absolutely. The cool thing about when you control uh, the things that you can control, airflow through the building envelope, the outside of your house, um, you then have better control of how the air is flowing in and out. So when you open your windows, you actually you can control which way the air goes. If you have a more airtight bathroom, you can use it to suck the air out of the bathroom when you're using a shower. Its ventilation systems become more effective when you can't control what you can't contain is one
Mm.
maxim.
Yeah, yeah. So if you've got, like, I mean, I've blown or tested a ton of houses in Adelaide, like older houses, where we literally moved the dishwasher away. Like, it was a house that was actually being renovated, thankfully, but this we moved the dishwasher away from its like location, and underneath the dishwasher was a hole. Like, I've got a photo of it. The hole was like yay big, and it was just a timber floor, timber subfloor, and there was just air and dust and bugs and who knows what else coming up into the house through this gigantic gap that no one knew was there because it was covered over by the dishwasher.
Oh, it's
Um,
crazy. Like
yeah, it's
it's
gross.
pretty simple argument to make to a homeowner. Look, we can seal up the paths for the bugs to come in or the rodents
Yeah,
to come in. That's what
I actually,
we're doing. It's like it's a pretty simple thing. We say like let's seal up the places where the bugs come in. People are like, oh yeah, please do.
yeah, I feel like that's a more compelling argument than energy efficiency. Just keep the
Yeah,
cockroaches and the spiders out, please, and the
sure.
ants. Yeah, for
Yep.
sure. And I know there's significant misconception around building airtight because the first thing people who don't know anything about airtightness say to me is, "But won't we suffocate?" And you mentioned before opening up windows. So of course you can open up windows and doors in an airtight home, but let's talk about the motto, the build tight, ventilate right. Is that's our
Yeah,
sort of the
sure,
thing
sure.
that we say.
That's one of them. Yeah.
What can you say about that?
Well, it's not possible to build too airtight. Think about the International Space Station. It's actually being decommissioned soon because it leaks. One of the reasons is that it leaks too much air, and it's too difficult to find where this air is leaking out. And they need to keep it super airtight to keep the people inside alive. Airtightness keeping people alive. Same thing with submarines. You can they can be underwater for months at a time in a completely airtight vessel. So the problem isn't that the building envelope, the submarine or the International Space Station, is too tight. Yes, people need ventilation um, to breathe. They need in those cases they need to get rid of the carbon dioxide and other pollutants so that people can stay alive. But no house is ever going to be that airtight. So I don't mean to. Um, uh, I like to say, if things are stuffy, of course you can open a window. You always can open a window. And I think people get afraid that they're going to feel stuffy or that the house might be moldy. And often the problem with the mold that we see in Australia is not so much is not only related to airtightness. People are building more airtight, but it's also that they're not at the same time providing ventilation to dilute interior moisture, and they're not doing other things about thermal bridging that are going to get rid of cold spots where condensation happens. So we are, I should say that building more airtight does increase one part of the risk equation. It creates more risk, and so you need to do other smart things. You can't. A house is a system. You can't alter one thing in the envelope like airtightness without paying attention to the other things like thermal bridging and vapor control. So it's a system, and once you start messing with those things, you need to make sure they're all balanced. So build tight and ventilate right is a simple way to put that.
Yep, yep. And a lot of Australian homes will ventilate using their windows and doors. There's this, the whole indoor outdoor lifestyle is very popular, entertaining, breezes, hearing the birds, all of that kind of thing. What are the other options for ventilating a home?
Well, actually, I think what you just mentioned, birds and things, and fresh air, that's great. The outdoor lifestyle is great. When the weather's great, please open up your doors and windows and enjoy that, the breeze. But one thing I think we don't talk about enough is that um, airtightness lends itself to comfort in so many ways. So not just drafts, also um, it's quieter when you can seal off the leaks from the outside. You hear less noise. One of the favorite demonstrations of this concept was Chris Nunn in his passive house north of Sydney. He shows, well, just next door there's construction going on and people building something. On a video he opened the door and you hear the big trucks and excavators outside, and then he closes the window and then it's just totally silent. It's so cool. And if you just tell people, look, we're going to help you build a house it's quieter and you have fresh air, the air is clean and quiet. Think of your house as a sanctuary. And isn't that a lovely selling point? I mean, this is what we're talking about. We're actually talking about controlling these flows, moisture, sound, drafts, cold, bugs. Get control of that and really make your house into a place that you actually like being.
Mm. For sure. I was doing a test yesterday for a soon to be certified passive house, and it's on a main road, and I experienced the same thing. Shut the door to start the fan, and it was just quiet. But I
Yeah.
was someone I have a particular like sensitivity to. I'm like sensory about noise. It's a
Yep.
thing for me, in particular. So yeah, I just the peace, and as you say, that word sanctuary, that's how I felt in this house. It was like, oh, it's like just that breath of like, oh, just like that.
Yep. It is. I actually think as a selling point for this to say, you know what? Wouldn't you like a good night's sleep? I would. I
Yeah.
would.
Yeah, and yeah, I mean, the we talk about airtightness in terms of energy efficiency and all those things that you mentioned, but acoustics is actually insulation is not the only way to control acoustics.
Oh yeah. No, actually,
Airflow.
yeah, for
Mm,
sure. So
mm,
Barry Cope in the UK, the director of Atma in the UK, his real passion in life is acoustics. So
yeah,
he's
right.
blower door testing expert, but he's also an acoustics expert. So he knows how closely those are linked.
Yeah, right. I didn't know that. Cool.
Mm.
Um, Speaking of Barry, we'll just go back a few steps because we were talking about Atma before, and we'll go slightly towards the regulations for a minute. So, blower door testing is not currently mandatory in Australia. Where are the places? So it's in the building code. It's in the National Construction Code 2022 as an optional way to verify the airtightness of any building.
Hmm.
So that's in the commercial code and the residential code. Where are the countries in Australia? Where are the countries in the world that blower door testing is currently mandatory? I know it is in the UK because Barry's all over that.
Yeah. So the UK is they have really embraced it. It's now required that 100% of buildings, including 100% of apartments, if you have 500 apartment building, you're going to test 500 times.
Wow.
So that's that's uh, that's one end of the spectrum, and another is where it's incentivized. So it's incentivized here in Australia. It's optional in the building code, and there are programs like Green Star from the Green Building Council that incentivize airtightness testing, and Passive House is a voluntary standard.
Mhm.
So that's the other end of the spectrum. But other countries like the US, some states in the US have adopted versions of the IECC, the International Energy Conservation Code, and that has um, testing, but it's only an option. I mean, it's not.
Okay.
Sorry, some states like state that I moved from, New York, it's mandatory there, and it's mandatory in Massachusetts, and it's mandatory in many other states. But the U.S., there's 50 different states and 50 different governments, so it's a
Mm.
patchwork of different versions of the Energy Code, and they're all at some level, some stage of adoption of testing.
Is it more like weighted towards the colder states?
Not exactly. So Florida's not warm at all, and that has blower door testing. Lots of parts of Texas
Yeah.
have testing as required. So not at
Okay.
all. I mean, California testing is very common in California as
Mm.
well.
Mm. Okay. Cool. Interesting. So yeah, going back, so the Barry told me a story about the UK where they literally have like you can't get handover unless you get a compliant blower door test, and he told me a story about literally moving vans in the driveway, but the blower door test fails, and therefore the homeowners aren't allowed to move in; they have to wait. Isn't that crazy?
That it's crazy that they let that argument go to that length before they finally stop people. Geez, I mean, yeah. But yeah, they're serious about it, and they're serious about it in the U.S. as well, the states that have it. So the ultimate authority is the code official. Most U.S. states they don't have private inspectors like they do here in Australia. It's employed by the state. So this each municipality or county would have a code official that you have to show your paperwork to, and they give you a certificate of occupancy. You don't get that certificate of occupancy unless you've satisfied all the requirements, and blower door testing in some cases is one of them.
Mm.
So
I want.
Yeah.
I wonder if we'll ever see that here. It's on everyone's mind.
I don't know. I don't want it to be painful, because
Yeah,
it doesn't have to be.
yeah.
So want this, the number one thing, I keep saying, I want the motto of Atma in Australia and New Zealand to be do something useful. Do
Mm,
something that actually makes a difference to someone's built outcome, to someone's life. We're not just trying to burn money here. We're trying to make the building actually better. A lot of buildings get zero uh, objective assessment of build quality. Like, think of all the things that even something as serious as um, fireproofing. So in apartments, the inspection for fireproofing is visual. You think about this is something serious, right? Like, we want to make sure that the penetrations between apartments are well sealed. We've got so many examples of people they're complaining about
mhm.
smells and noise from their neighbors. And when the blower door tester goes there and uses a fog machine on this apartment, and they go to the next apartment where they are complaining of the smells coming from, they see smoke pouring from the walls and the light fixtures and things. And what's going on there? If you look behind the cabinets in the bathroom, there's just no plasterboard back there. Like, they just didn't do it because they thought, well, you're going to put the cabinets there and no one's ever going to see that, so we're all good. But like, these are really, really big holes that if there were a fire in one apartment, they could really cause a problem, a real life safety issue in the next apartment. So the fire inspections, which are visual and subjective about whether something's good enough, it's not good enough
Mm,
for us. And we could do a lot better by doing some simple, objective tests with a blower door to say it has to be sealed at least this much, and
mm.
then just draw a
Absolutely.
line.
Absolutely. I've done a few commercial blower door tests where the fire doors aren't sealed, smoke coming through them, and plant rooms and things that are supposed to be sealed. They're supposed to be sealed for fire, right? Plant rooms? Yeah,
If,
not
yeah,
at all.
let's say again.
The plant rooms are supposed to be sealed for fire, right?
Absolutely, yeah.
Yeah, yeah. Well, I've seen many that aren't at all.
Yep. Yeah, and I think so. A lot of those things could be tested qualitatively and quantitatively.
Mm,
You could get
mm,
a number on them. Yeah.
yeah. It's time for a quick sponsor shout out. Today's episode of the Building Sciology Poddie is proudly brought to you by our amazing sponsors, Enduro Builders and ClimaSure. A huge thank you to these incredible businesses for supporting the podcast and helping us spread the word about better buildings to live and breathe in. Your support makes this podcast possible. Please head over to their websites and follow their social pages. Okay, next question. Still on the regulatory stuff, NatHERS star ratings and airtightness is something else that is an up and coming development in Australia. So NatHERS is the National House Energy Rating Scheme in Australia, and that is how we get our star ratings for energy compliance. When you build a house, you get a star rating. Right now, the minimum compliance number is 7 stars. It used to be 6. It's just gone up to 7. And there's been talk for quite some time that I believe you have been pushing, Sean, about including airtightness as an upgrade or as a specification in a star rating, because there, as we know, the assumed level of airtightness in a NatHERS model is not at all necessarily what gets built on site, and no one's checking to make sure they match up.
Yeah.
So the energy efficiency of what goes into your model usually doesn't match what gets built. So this airtightness number is quite important. So could you give us a bit of an update as to what's going on there?
Sure. So, Department of Climate Change, Energy, Environment, and Water, they're the ones that run NatHERS, which is the National Home Energy Rating Scheme. They commissioned a study over the past 2 years that I was heavily involved in, where ATMA members around the country, or in several states, did testing under the ATMA scheme and submitted the data to ATMA lodgement so that we could analyze what is the typical level of airtightness being delivered for new homes. So these homes had to be built within the past few years and had to, by definition, we wanted to find ones that were normal. So there were some that were sort of aiming for passive house, and wanted to be included because they wanted a free blower door test. Why not? The offer was for a free blower door test. But really, we declined projects like that and wanted to find typical, which most homes are typical. And I don't blame people for saying when they answered the questionnaire, was airtightness a high priority for your construction? Most people said no. And I don't blame them. Most people are just looking for the first place that they can afford. Like, what is the first house that you can afford? If you ask me, would airtightness be high on my priority list if I could afford to buy a home? No, it wouldn't. I can always do something like that and make that better later. But first, people just want a home, please. So we're trying to really look at what's typical. And what we found is the results were a little bit better than probably the average assumption in a NatHERS model would be. So if the average in a NatHERS model would say the house should have a permeability, which is air leakage per unit of surface area of that house, a permeability of 8 cubic meters per hour per square meter. The typical result from this study we found for single-story houses was around 6.5 or something cubic meters per hour per square meter. And for double-story houses, it was about 7 or 8 cubic meters per hour per square meter. So, but both of those are tighter than the average assumption in the NatHERS model. So what this means is that was the average, actually. And so it means that people often there are some people that are being promised a house that was pretty airtight. So if you consider 8 to be airtight, they're being promised something like that in the energy model, but then what they're actually getting was more like 10 or 12, 14, so much leakier. So that's disappointing that they're not getting what they paid for. But then there were many that were getting much tighter than what they were expecting. And so, if you're looking for energy code compliance, there's different ways you can get the energy savings that need to represent the energy efficiency of this house. So you could do more insulation, you could do better windows, you could do better heating and cooling systems. There's lots of different energy efficiency measures, but airtightness is not really one of them. It's not a lever that you can directly pull in your energy model. So what this study for CSIRO showed was there's actually an opportunity here. So a lot of builders a lot of them, by definition, we wanted people that really weren't trying extra hard for airtightness. So without even really trying, a lot of them were getting better than they're getting credit for in the energy model. So there's an opportunity for a lot of construction to get credit where credit is due for doing better than assumed. And so we see it as a big opportunity to help drive the industry because we saw not only were they doing better, but we also saw so many huge problems, code violations, actually, like no dampers on the bath fans when they should have a damper, and a lot of really dumb practices and just poor workmanship, that easy fixes all of them. That you could, if you're looking for energy savings to get your NatHERS star rating, there's some easy energy savings on the table here. So we see it as a big opportunity for helping drive positive change.
Yeah, massive opportunity. So now when the energy modeler or the consultant is modeling up your house in the NatHERS star rating tool, instead of increasing the insulation from, say, R2.5 to R2.7 in the walls, for example, they can go to a different field and they can say, let's aim for a permeability of 5 cubic meters per hour per square meter air tightness score. So they can enter that instead, which is less than the assumed level of air tightness in a typical model. So that is used as an upgrade. Is that how it works?
That's how it will work. Yes. So that's what we want to be able to do. This is how it works in the UK, where Atma has been going for a long time, and Atma lodgement has been in use for more than 10 years. So you put into the energy model what's your target, and now the target is creeping down and down and down because the industry is getting better and better and better. So it's getting very close to a permeability of 4 is the average assumption in the energy model.
Right.
And so if you state on your energy certificate, your energy model, that we're going to get 4 or less, then you have to do your blower door test and you have to get 4 or less. Otherwise, you don't get your certificate of occupancy. You're not doing what you said.
Yeah.
So that's why that number is creeping down. So um, that is coming to Australia. It's coming to NatHERS, hopefully as soon as possible, but maybe later this year. But even a step shorter than a step short of that, to just state, like you said, when you put in your energy NatHERS model, we have this many downlights and this many windows and this many brick vents and things like this that you put into the model about what leaks will exist in this house that isn't yet built. You put this into the model, it generates an airtightness figure that it uses in its calculation, but no one ever sees that. It goes into a black box and no one ever sees what that number really evens out to. So what they're going to start doing, hopefully soon, is just state on the certificate, what was the assumption, please? Just tell me what you were aiming for, what this star rating is based on. What assumption did you use for airtightness? And then let me check it. Because what we'd like to show a lot of builders is, hey, look, you in the model it says your permeability should be 8 or less, but you got 4. And look, there's energy savings that you're not taking credit for here. You could do this. And not only that, but I see some big leaks that you could fix for close to no cost. You could get some major energy savings by just doing a little bit better with the airtightness. So it's a huge opportunity.
Yep. Yep. And how would somebody achieve an airtightness? Like if someone came to you and said, "Hey, Sean, I'm building this house with such and such builder who knows nothing about airtightness. How can I make sure that I achieve my airtightness goals?"
Um, a lot of this stuff is super basic. So one thing I often point to is the Building America Solutions Center. It's a website of the US government with tons of free resources about how to do basic air sealing. All the stuff they have there is super simple. It's using available materials on site, like a lot of the leaks that we find are missing plasterboard or something. So you talked about the washer. That's a big one. We find ovens in Australia leak. It's not the oven that's the problem. It's the fact that behind the oven, they didn't just use plasterboard all the way on the wall. So you can basically, if you move the oven back, you could access the wall very easily if you were a rat or a cockroach. So that means a lot of the stuff, we're just talking about some cheap stuff that's there by the truckload already. Plasterboard, caulk, stuff like that behind cabinets, just boxing out cavity sliding doors, just some basic seals at where duct registers meet the interior finish. It's all really cheap and simple stuff that all add up to pretty big gains in airtightness.
And what about the red pen test? Could you explain what that is?
Sure. The red pen test is where a designer or an advisor like yourself or a NatHERS assessor could look at the plans and say, look, I see this border between the garage and the house, and there's a bathroom bordering the garage here, but I know that the bathroom is going to have a bunch of penetrations, plumbing penetrations in it, and it's bordering the garage. I bet you're going to get communication leakage from the garage into the bathroom wall because of this. It's easy to see those things. It's easy to see this on a house that hasn't even been built yet. So with the red pen test, you can trace around that house to say, where's the air control layer going to be in here, and see where some likely problems are going to show up. And you can see that years before a building's built.
Yeah. So you just draw that on the floor plan, right? Like,
yep.
Yeah, you just get the architect. It doesn't even need to be a detailed plan. It can just be the concept plan, like literally basic drawing. And the pen doesn't have to be red. It can be
That's
any
right.
color. It's just a nickname.
Yeah.
And you just draw a line, and that tool is used to communicate with the construction team, right?
Mm-hmm. Yep, absolutely.
Yeah, because if we can draw all the red pens we like and we can specify all the airtightness we like in the NatHERS model, but if the carpenters and electricians and plumbers and plasterers on site don't know that there's an airtightness test target, or they don't know that there's a blow door test being done, then they won't worry about their attention to detail.
Yeah. So there are studies. There's a study done by ASHRAE, for ASHRAE, that showed what it was trying to find what's the difference between buildings with a quote air barrier and without a air barrier. And they found a really big difference in performance between those with a declared air barrier. And so what's the magic in that? Is it just declaring that you have an air barrier? Well, not really. It's like it's number one is looking on the plans to say, here's where the air barrier will be in this building and defining that, it's specifying that. And then it's also, so it's something you can point to on the plans, but it's also something you can point to in real life to say, this is where the control layer shall be. And so you can say, look, on the drawing here, I have a nice big red line here. It says there should be air control here. Look at all these things that are penetrating here. There's missing plasterboard here. The plasterboard doesn't go all the way to the roof underside. So like you can point to it on the plan and point to it in real life. That's where the air barrier should be.
Mm. And there are so many things that you don't even think of until you think about airtightness as a thing that you need to address. Like you said, cavity door slide, like cavity doors. Never occurred to me that they would leak air, but they are literally a hole that is open to the wall, which is open to the roof.
Yep.
And if you've got a couple, 2 or 3 cavity sliders in your house, that's massive.
Yeah. And there's other things. There's other things like interesting for the study we did for CSIRO, testing houses with building cavities like wall cavities as ductwork, like a return. It's kind of funny. We're trying to find a correlation between when we remove the register, we'd take a look inside and count the number of dead crickets in the wall, and we're trying to find out, is there a correlation between the blower door number and the number of dead crickets in the wall? And there does seem to be a correlation between number of dead crickets. So I'm not saying that's a good code compliance strategy, but
less than 2 dead crickets.
Yeah, we want 0 dead crickets is the goal. 0 dead crickets would be the goal because you only want air to go in and out of your duct system, not crickets.
No, and you don't want your air to go in and out of the wall cavities.
Yeah.
Okay, good. Thank you for clarifying the dead cricket measure.
Yeah.
So CSIRO study, we've sort of danced around that. So could you give us just a bit of a summary of, because this study was done twice. It's been done twice now. So the first time you were involved were you involved in the first one?
I was not.
No,
it was
you
right
came
before,
just
it was
after.
published in 2015, and when I got
after
here,
you.
I was shocked. And was just shaking my head for many years afterwards to say, wow, the average air tightness that they found there was 15.4 air changes per hour for houses around the country, which is shockingly bad. And the average we got this time was more like 7 or 8. So about half that. So what the heck is the difference? These two studies were done 9 years apart. Why is the leakage down by half? Well, two big things that I think really stand out, and then a third. The third one is that I think there's just more awareness for that houses need to be sealed, and we're not afraid of sealing up houses. So there's more general awareness of that this is not a bad thing to seal up houses and walls, at least. But there are some changes in practice. So when I first got here, it was very common to find houses being built with no exterior water-resistant barrier, no exterior wraps, just bricks. That was it. And like they used to build them 100 years ago, building them that way in 2015. I got lots of pictures of that. I was kind of shocked. No sheathing, no wrap, no nothing. But it became more common, and now it's basically universal that every house now has a sarking or a membrane wrap of some sort to repel water, which is just good building practice to keep the water out first. Control your water first, and then go after air leakage second. But just using the wraps on the outside that's a big first step. Could do a better job with it, and we'll see some major gains from doing better. But that I think is a big difference between now and back then. Pretty universal wraps, use of building wraps. And another one is just some of the products now are just better. Like the bath fans leak less than they used to, and things like downlights, we counted the number of downlights in the houses because we wanted to see, or actually wanted to prove that the number of downlights used to matter to the leakage of the house because all these halogen lights everywhere, they just leaked a ton. And so you got like a lot of the houses has 50, 75 downlights in them. It's a crazy number, but each one of those used to leak a lot. And so if a house has 50 downlights in it and each one of them leaks, that's going to add up to quite a lot. Whereas now we directly measure the leakage through each downlight, and it's very little. The new LED lights that we have that are all IC rated, they can just put insulation right on top of them. No reason to have lots of space and ventilation around those. They're pretty tight and they don't leak. So those are some big changes. Changes in products, changes in practices. We're just building more airtight.
Yeah, yeah. And also the first test, the first study only had a fairly small sample size, didn't it?
Mm.
It was a much
Yes.
smaller sample size.
Yeah, 20 houses per state. So including it was Victoria, New South Wales, ACT, Queensland, Tasmania, and WA. Whereas this one had this one we just published last year was just Victoria, ACT, of South Australia, Queensland, and New South Wales.
Yep.
So yeah, a little bit, but each one fewer states this time, but many more per state. So it was more like 50
Yeah.
homes per state.
Yeah,
this
it was
time.
like 3 times the number of houses were tested. So it was a much better
More
sample
statistically significant.
size.
Yep.
Yeah, yeah.
Yep.
Yeah, so I will link that study in the show notes for anyone who
Yeah.
wants to go and have a look at that.
Take a look at the scary pictures at the end of the report because there's a lot of big leaks there and things that we really should focus on. There's some that are really a big one. Ductwork is a big one. It's not the ductwork itself that's leaking, it's the connection of that ductwork to the interior finishes and the use of building cavities as ductwork. We just got to stop that. That's a big one.
Yep. Cool. So what are you working on at the moment? Anything interesting?
Well, we're trying to help bodies like the Green Building Council to take a step out ahead and lead the way for the building code to say, yes, we can do this more widely. So incentivize testing of whole commercial buildings, like large commercial buildings, through extra credit. It would be great. So things like that. We're trying to push NatHERS to just be upfront about what the assumptions are in the energy model, and then also incentivize better practice by giving credit for better airtightness. Those are things this next year. We're also doing a push in New Zealand to raise awareness and to show the Kiwi authorities that airtightness is within reach as a viable savings strategy for getting carbon savings for their country, for sure. So those are the pushes. I mean, if you asked me 5 years ago what were the pushes, that would have been the same thing. But
yeah, it's a slow-moving boat, but
yes,
I think that it's not stationary. There are things are moving forward. It is, but you do have to really care. Because
yes, you do. You got to be patient. You got to be patient.
Yeah.
Something about building codes and standards. You got to be patient. Nothing happens fast.
Yeah,
It's got to be persistent.
Yeah. One day things will. You look back and go, "Whoa, look how far we've come."
Yep, it's a marathon, not a sprint.
Yeah, absolutely. All right. Well, my last question is: what is the one thing you want people to know?
Well, if it were, I think for the listeners to your podcast, I think probably not so much an argument you need to make to homeowners that airtightness is a good thing, because I think you could make that argument that about livability and comfort and air quality. Those are valid things you can get for an airtight house that's well ventilated. But I think the main message would be to builders that really, guys, this is not that hard. We can help you do it. When you see the blower door and you feel the air leaks yourself, where they're coming from, you're going to be infected with this bug that makes you think, why is that happening? Why is this thing leaking? And how do I it's just going to bug you that you can't figure out why that's leaking. And so you will get infected by this bug and try to do better and try to do better. That's the cool thing about comparing numbers is you're always going to try to do better, mate. Try to do better than the next guy. So let's start a competition for who can build better and better.
I like that, and I can vouch for that. I've seen many builders come to my build or tests, and they're like, they're like, wow, what's going on there? And they don't they're not afraid of it at all. They're really interested.
Yeah, it's cool.
Yeah,
cool.
I like that. Cool. Thank you so much, Sean, for joining me. That discussion was fantastic, and I'm sure everyone got quite a lot out of it. So thank you very much for joining me. I appreciate it.
Yeah, thank you very much, Jess. All right. Okay, bye-bye.
That is all for today. Thanks so much for tuning in. There will be another episode in a fortnight, so if you would like to listen into the types of conversations that I have all the time, please subscribe on your chosen platform. Rate the show, leave a comment, whatever you like, share with your friends and family. I'd love for you to spread the word about the Building Sciology Poddie. There's a link in the episode description where you can head to a landing page, and there are some show notes there with relevant links and a full transcript of the show as well, and also links to my socials. So if you're not already, I'd love for you to follow along there too, as I share lots of building science and building biology tips. There's also a contact page where you can send me an email or even a voice message. So if you've got questions or suggestions or guest ideas, I'd love to hear from you. I want to know what you want to know, so please get in touch with me. Thanks again. I'll be back in 2 weeks, so until then, happy healthy building.